Hello, good morning, everybody. Your due now is in Google Classroom. I'm going to take attendance really quick. Hi, Janaya. Miguel, Cameron, Kiana, Samaya, Wendell, Kamarian, Demia, Janaya, Denaya. Hello, lovely. Joseph. It's not here. Darn, I like Joseph. Eric. Ayana. Hi, lovely. Stephen. Josiah. Kamara. Kamura. And Messiah. All right, everybody. I'm going to give you another 20 seconds or so. Wrap up your due now. Log in quick. Log in quick, lovely. Your due now is on the board, but you will answer it in Google Classroom. Shut up. I see I already have 12 of us who've turned it in. Thank you so much, Cameron, Kiana, Samaya, Wendell, Kamarian, Demia, Janaya, Stephen, Josiah. Thank you, thank you, thank you. Once you're done with your due now, open up your wildebeest population data assignment, complete question 3, start on that. We're going to talk about it in just a second. Several of you guys weren't here because you were on the field trip, and I understand that, which is why I'm going to model for us through question 2. I'm going to go pretty quick. Remember, if you're still struggling with it, especially if you were on a field trip, you weren't here, please email me or see me in office. I'm going to have a video up about how to use it as well. So if you go home and you're still confused, you can watch the video. Okay? Right. My students have been struggling with this particular assignment, so I want to make sure I'm providing you as many resources as I can. Speaking of resources, let's take a look. Raise your hand if you weren't here on Friday, by the way. 1, 2, 3, 4, 5. Okay. So for the 5 of you, I'm definitely going to make sure I go through this. When you open up wildebeest population data, this is what we did on Friday. We also did a short quiz about evidence. You'll have to complete that on your own time. But this is what you see as soon as you open up the assignment. We have this graph of the population data up here, and this is data from 1961 to 2012, where people were essentially counting how many wildebeest there were. We have specific numbers that we can work with down here. This is how we'll be doing our calculations. We have these numbers that we can manipulate here. And yeah, you heard me right, calculations. This is the lesson where we do the most math out of anything that we'll do in the first semester of biology. Now, and when I say most math, it's really just kind of a plug and chug. For question 1, all you have to do is compare that graph that we have up at the top to the graphs that you made in your kinesthetic model. If you compare those 2 graphs, you should have 2 similarities and at least 1 difference. But we're going to focus here on the part that most people are struggling with. We have this disease, it's called Rinderpest in 1960. Before 1960, this disease called Rinderpest was killing a bunch of wildebeest. Can you say Rinderpest? Rinderpest. Thank you. Now, rinderpest was a major limiting factor. We started vaccinating against it in the early 1960s. By 2011, the disease is off the base. It no longer exists, which is very helpful for all of us who like meat, because cows tend to die of it a lot. Your first part for question 2, for part 2A, you were expected to use that information to describe what happened during these years, 1961 to 1977. in terms of limiting factors. These are those years. It's clearly going in which direction? Which direction is it going in? Everybody? I don't hear some people. Oh, which way are we going? Yeah, there we go. It's going up. Absolutely. And you should tell me that that has to do with the limiting factors. We know before this, what was our limiting factor before 1960? Yeah, the disease. And what was that disease called? No. Rats. What was the disease? Rinderpest. Everybody say Rinderpest. There we go. Yeah, we had the disease called Rinderpest before 1960. That was our limiting factor. Now, we have a new limiting factor, and we talked about what that limiting factor is in all this whole time, essentially. What's our wildebeest's current limiting factor? Currently? Because we got rid of the disease, right? What is the limiting factor for wildebeest? What do wildebeest eat? What's their limiting factor now? We did a whole kinesthetic model where we showed how the limiting factor determines how many wildebeest we can have. So one more time, what was their limiting factor? There we go. So up here down here we have disease as the limiting factor. And over here we have grass. That takes us to where we are in question 2b. This is where we do some calculations. And as a quick reminder, I modeled this for us on Friday, but just because it's been the weekend, we have this equation right here. It tells you exactly what to do. We have y2 minus y1 divided by x2 minus x1. The first step that we have to do here is just identify, okay, what numbers go here, right? We have some years and we have a number of wildebeest. What is my x value? X is? Yeah. And what's my y? 1. How many wildebeest I have? The wildebeest population. For each year, for each period of time, we have x values in terms of years. We have y values in terms of the number of wildebeest that we had. What years am I looking at for this first part, 2b? In your assignment. Say that louder. 1961 to 1977. Absolutely. And which year is first? Yeah. So if that's the first year that I'm looking at, then that's going to be my x1 or x2? Yeah, that's going to be my x1. It's the one that happens first, right? And so this must be my x2. And y1 and y2 are the same way. This must be my y1 or 2. Exactly. y1, y2. This whole equation here, now that we've identified these, all we have to do is plug them in. And one more time, this is our equation. Y2 minus y1 divided by x2 minus x1. Note, the 2's are first. The 2's are first. Always. Always, always, always. So let's do this one together. I'm going to model this with you. My x1 goes there, my x2 goes here. Let's start with x2. x2 is what? Yep, 1977. What's my x1? Yes, 1961. And now, y2 and y1. These are some big numbers, okay? Big numbers can be intimidating sometimes. They are for me too. The number one thing that I see students do wrong is they just miss a number in here. There's a lot of zeros, there's a lot of ones. Sometimes students miss a number, so make sure you show your work. Because if when you're putting these into the calculator, you miss a number, but I can see you set this up properly, I can still give you full points, even if the number is a little bit off. So, my y2, that's 1.4 million. There are 5 zeros in 1.4 million. There are 5 zeros. How many zeros? make sure that when you put this in the calculator, you have 5 zeros in there. 1, 4 with 0, 0, 0, 0, 0. That's 5 zeros. That's our y2. We're going to subtract from that our y1. That's 2, 6, 3, 3, 6, 2. Now that we plug these in, all you have to do is go into Google. You're going to type in these calculations. Let's do that together for this one. Okay. So my y2 minus y1. 1, 4, 0, 0, 0, 0, 0, minus 2, 6, 3, 3, 6, 2. That's my y2 and my y1, right? Yes? Right, Kanaya? I know you weren't here. I want to make sure you're getting this. And that's my answer. For the first part. Because I still have to do something. I still have to divide by the difference in my x1 and x2. So that's my answer. I'm going to copy and paste that because it makes my life easier. And now 1977 minus 1961. I want you to follow along with me. And don't worry, you'll be doing the next couple of questions on your own. So make sure that you understand how to do this. I'm modeling it with you. 1977 minus 1961 gives us 16. So I'm going to take my answer from before and divide it by 16. That gives me my wage. There we are. Make sure that you type in your work as well. Yes, of course. 2B. We're on question 2B. Okay. So once again, this is the formula that we use. This is how we set it up. Go. Give me a number of air checks from 1 to 5. 5 being you feel confident about, so you can put on your 1 being I don't know what to feel. Give me a number of air checks. You don't have to tell everybody what you're doing. Set up our next problem together, but I'm not going to actually run the calculation. Alright? But for this, I'm going to skip 3A for just a second because I want to get into the math. Alright? Yes? Yeah. Okay. We'll skip 3A for just a moment. But for question 3, we're dealing with 1977 to 1978. 1977 to 1978. Which one is my first year? 1977. Bingo. So that's going to be my x1. And which one's my x2? Therefore? 1978. Bingo. That's my x2. Now we need to know what our y1 and y2 values are. So we're looking at 1977 and 1978. And one more time, our equation is this. y2 minus y1. I have this equation written in your criteria for success, right there. That way you can't forget it. y2 minus y1 divided by x2 minus x1. That's our equation. We said x1 was 1977, x2 was 1978. So we have something over 1978 minus 1977. What is my y1? What's my y1? Those are x values. Remember, time is an x value. We on three? Yep. Wait. That's a question. Yeah, sure. Which one is my x? Years or will it be population? Population. Right. So my x is years, right? My y is. There we go. So if my years are my x values, I put those down there. Now my y values. We have that 1.4 million again, right? How many zeros are there in 1.4 million? I. 1400000 minus my that's my y1 value. So I put it in the wrong spot. 1400000. Now my y2 value. What's the second number? What's my second number up here? Then you can have it in your solution. Well, 1, 2, what? 4, 8, 9, 4. There you go. 1, 2, 4, 8, 9, 3, 4. And that's a lot of digits. Like I said, all day today, like 30% of the students have been like, wait, Mabel, is this right? And I'll look at their stuff and they've clearly just missed it. They forgot to put in this 9 here, and so it threw off their whole calculations. Make sure you show your work so that I can still give you full points, even if that happens. Okay? Now, I'm not doing this in my head. If you can, I'm very proud of you, honey. But I cannot. So I want you now to complete this equation by Googling. Use the Google calculator to subtract. Now, one thing. Do you think are you going to end up with a positive or a negative value? You should. There's a typo in your criteria for success. It says you should end up with a positive value. I apologize for that. You should end up with a negative value here. So, do this calculation. This will be your answer to part 3B. And I'm going to come around to support. Now you want to go? Yes. Bingo. Yep, bingo. You got it. Now, answer part 3A. Better. Well, what's 1978 minus 1977? Well, what's 1978 minus 1977? This you should be able to do in your head. Well, these things cancel out, right? The 197. So now you just have 8 minus 7. Which is? Yeah. Now what happens when you divide that number by 1? Does anything happen to it? So you have the answer. No, the answer is what you had before, this. Yep. Yep. Okay, you got it? There you go. Nicely done. Now, that's part you put that here. I want you to put it down here. Now answer part 3. Remember when we skipped that? And now I did a little out of order. I just wanted to help with them. Okay. Once you're done with your calculation, you can go to part 3A. Finished? Finished? Yeah. Take a look here. So we're looking at this stuff, right? Did you set it up that way? 1, 2, 4, 8, 9, 3, 4. Minus, what do we have up there? Type that in. Yep. Okay. Now all you gotta do is type this in. That's simple. Now, 1978 minus 1977. Now, what's 1978 minus 1971? Yes, yeah. Divide that by, what's 1978 minus 1977? 1. So do you have to do anything when you're dividing by 1? Not here, right? So you have your answer. Bingo. Yes. What's 1978 minus 1970s? Just one, right? I mean, you can feel free to divide by 1 as much as you like, and change what you like. So in this case, we're just dividing by 1. Which really help. So the whole is 1 year difference. If you can hear me, clap once. If you can hear me, clap twice. Hi, lovelies. So a lot of us got this right. Fantastically done. For part 3A, which remember, we skipped that. Part 3A, I do need you to answer that as well now. We have this negative rate of change. What does that mean was happening to wildebeest? They was dying, right? Bingo. We had some wildebeest dying. Do we have any wildebeest dying in this time period? Were any wildebeest dying in here? Yeah, they were just increasing, right? So we didn't have any deaths there. But now, between 1978 and 1977 here, we have some die-off. Was it rinderpest that was killing them here? At this point, we've cured rinderpest, right? So that's not what was killing them here. If so many wildebeest died, like 151,000 wildebeest died, what killed them? Say that again to me. What killed them? Starvation. Bingo. Our new limiting factor is food. So a bunch of them died because they ran out of food. Yes. Now we're on part 3A. Part 3 is asking you to explain the role of limiting factors in causing this change. Now, several of you are still typing, and I see that, but some of us are done. Yes? Just give me 1 second when I finish. For question 4, and I'm chunking this into bite-sized pieces for us. For question 4, we're looking at a different time period. Where's my mouse? There it is. If you can hear me, clap once. Take a look at the board for me. I'm going to explain question 4, then come around and provide some more individual help. Question 2, we were dealing with this time period. Question 3, we were dealing with just this time period. Question 4, now we're dealing with this time period. Take a look at that. And just in a sentence, what's happening to the wildebeest? They kind of go up and down a little bit, right? But are they changing significantly? No. We saw this in our simulation as well, right? And you all told me before, if our simulation continued for 50 years, it would just kind of stay the same. We haven't continued. Is that what we're seeing here with one notable exception? Bingo. We're seeing them more or less stay stable. And you'll be able to see that because your rate of change, well, how big do you think your rate of change will be? Are we talking like this? What are we talking about? Yeah. What are we talking about, Anna? Talking about big rates of change or little ones? They're changing a lot? Or not really? You too? Janai, you can go to the restroom. So, Anna, take a look. Have we changed? Look at this third bit here. We go from here all the way to here. Are we changing? So, what will our rate of change be? Like we want it to do, not very. Not very. Not very, right? So your rate of change, you're still going to calculate this, and it should be a pretty small number, at least in comparison to the other ones. Think you can do this on your own? Yeah. No? Okay. I don't know. Let me just, you're still confused? Give me a thumbs up if you're still confused. Okay, stop. Let me give you some practice. Let me do another one. Imagine that I'm trying to find out, oh my gosh, how many pizzas were sold at a pizza shop between and over the course of a couple of years. And there are 2 points that I need to worry about. 2000, the year 2000, and the year 2010. I want to know how much did my pizza shop change how many pizzas they were delivering over that 10-year period. Everybody good with the premise? Good. Now, in the year 2000, I delivered 100 pizzas. In the year 2010, I delivered 200 pizzas. Real simple numbers. What do I have? Okay, if these are years, and these are pizzas, writing that is hard. Which one is my x value? Yeah, yours is the x value, right? That one's on the x-axis, it's at the bottom. That means it's my x value. And my y value, therefore, must be pizzas, because that's on the left. So, for each of these 2 points that I have, each of these points has an x value and a y value. That's always true on a graph. So this point has the x value. What's its x value? Yeah, and what's the value for x? Yep. So this point is 2000, comma, what's its y value? What is it? What is this? So I want to make sure everyone's following along. What is my y value for this point? Everybody? Thank you. 2,100. X, y. For this one, I have very similar x and y values. What's my x value? Yeah, 2010, comma, y value is 200. My equation, yes. Yeah, I know, because it's a glare, right? You can try angling it a little differently. Maybe. Don't. Great. There we go. Does that help? Perfect. Okay. I have my x and y values. Which one is my first point? Which one is my second? Which one's my first one? Yeah. This one here. That's my first point because it happens first. And this is my second point. So my equation. Someone you state. What's my equation for me? Yes? What's my equation? Well, first, the y's and the x's. Y1 minus, yeah, y2 minus y1 over x2 minus x. Yes. Say it with me now. Y2 minus y1 minus y1 divided by x2 divided by minus x1 minus x1. And we have our values here. We know our x1 and our y1. We have our x2 and our y2. All we have to do here is plug it in. So when we plug this in, our y2 is again 200 minus y1. Oh, that's yes, y1 is 100. And you don't need a calculator for this. What is that kind of equal to? Yeah, that's 100. So 200 minus 100 over x2. What's x2? 2010. Oh. What is my x1? 2000. And you don't need a calculator for that either. 2010 minus 2000 is. If I cross off the 2 zeros, what am I left with? 1,000? Wait, what is it? What's 2,000 minus 2,000? Yeah, 0, right? So then I just have my 10 left. So what's my answer? Yes. 100 over 10. I simplified this equation now. And so what's 100 divided by 10? 10. My rate of change here is 10. And what that tells me is that on average, every year, on average, I went up by 10. That means that on average, if this was my first point, this would be my second, this would be my third, this would be my fourth, fifth, sixth, seventh, eighth, ninth. I kind of was off a little bit, but they're going up by 10. That's what it should tell me. Let's go back to our actual wildebeest. Yes. Let's go quick. Let's go back to our actual wildebeest. Now, give me a number from 1 to 5. How confident do you feel about doing rate of change now? Give me a number from 1 to 5. 4. Okay. Feeling better? Generally? Okay. I see at most tables we have at least one person who seems somewhat confident. Okay. So, tell you what. As a table, I want you to set up this equation for question 4. We're looking at 1978 and 2003. So find which of those is my x1 and which is my x2. Then go back up to this data table and find your y1 and your y2. I'm going to come around to check and support. I just want to see that you've set this up right. Think we can do that? All right. Yes. You don't have a table. You got to write it down. It's okay. Mm-hmm. Okay. Does that look good? Wait. What are you confused about? I just want to Let's find out. See? Well, our data, you're saying that's 2003, so that's our x2, right? 118,396. So that's my y2 minus 1977. That's 508.84. Yep, you set this up right. So take that and divide it by 25. You got it? Yes. Show me what you got. Okay. And you set this up right? Yes. Looks good. Now make sure you divide that number by 25 and you're good to go. Yes? So close. That is perfect for part 3B, this one up here. That's the correct answer for that. Now I want you to do part 4. Okay, do the same thing, but for 1978 to 2002. Okay? Yes. What you got for question 4? You are off. You have one extra digit somewhere. Because this just that divided by 25. Yep, so you have an extra digit. Okay. 6, 4. 6, 4, 9, 6, 8. Yes, there you go. I'm glad you showed your work because we were able to identify that. Everybody over here good? Yes. What's your next? Is this right? That's a great question. Let's find out. 1978 minus 2003. I mean, I should have flipped that, but we'll instead. Yeah. 2003 minus 1978. There you go.
Okay, so I can answer now.
Yep. Go ahead.
Wait, that's right.
You set it up properly. Nicely done.
Okay, so all right. They both of them. So
Yeah. And now take this and divide it by this. Yep. That's the last part you got to do. This number divided by that one.
All right, got it.
Time we go. All right. If you can hear me, clap once. If you can hear me, clap twice. I've been table, and at every table there's at least one person who's got it right. So I assume you're all good, right? No? No? Yes, no, I no. Okay. If you are not clear on how to do this, email me. Right now. Yes, email me right now. Right now. I'm planning on recording a video of me going through a couple of these examples. So if you email me, I can email you that video and hopefully help you with it further. Sound like a plan? Sound like a plan? Alright. With that said, for question 5, that's a long computer right there. For question 5, all you've got to do is take your numbers, put them in this chart. From 1961 to 1977, you found the answer. We found it together. It was 71,069. 71,069, is that right? No, what was 7,031. 71,030. Yeah, with the decimal, right? Now, okay, 71,039. Then put in your answers for the other two. We talked about how limiting factors changed between 1960 and 1977. That's what's responsible for our increase. Talk to me about that as a really brief 1 or 2 sentence thing in this box. We've got 5 minutes left. I want you to fill out this chart now. Yeah, I did forget to find someone on Friday. You will be. Have you finished with question 5? I remember this now. So this was a tough decision. There were only 3 students who successfully included evidence in their wildebeest and rainfall assignment. Those 3 students were Janaya, Joseph, and Naziah. So because of that, those are the 3 students that I had to choose from. Now, in those terms, there is one student who has done more emailing with me and more asking questions than the other. Which is why I am going to give our clown for the week to Janaya. That's what I needed. Thank you so much, Princess. You may read all of the 5. Remember, I reward self-advocacy in my classroom. If you guys are doing the things, but one person is advocating for themselves more than the other, that's the thing so yes. Yes. It's the same thing. Try to come.